Hello everyone, welcome back to Math with Gustavus. Today we're going to look at fractions, but more specifically fractions with mixed operations. Whenever you're given a question like this, the first step that I recommend is rewriting the problem in a horizontal form. So this is the first step. As you can see, what I've done is to put the numerator in a bracket by itself, then I've replaced the fraction line with the division sign, and then I've also placed the denominator into a separate parentheses. Up next, I recommend converting all the mixed numbers to improper fractions. Now, the technique in doing this is simply multiplying the denominators by the whole number, and when you get that product, you now add it to the numerator. So watch and you'll see how I will convert each of them. Alright, so it's 3 times 3, that's 9, which is a product. Then 9 plus 1 will give us 10. After we add the product on the numerator, we always put back the denominator that's there. So in this case, the denominator is 3, so we'll put back 3 right here. It is the same process to convert this fraction, which is 5 times 1, 5 plus 1 give us 6, which will be 6 over 5. As you can see, I simply put back the multiplication sign, which is there, and I'll now put back the denominator, the division sign rather, and I'll now go ahead and convert these. But if you look closely, you'll notice that the fractions in the first parentheses is the same fraction as in the second parentheses. So you don't need to multiply and add right here. You can just simply rewrite them, which will be 10 over 3 minus what? 6 over 5. Alright, cool. So now, after you've completed the second step, which is to convert all the fractions to, all the mixed numbers to improper fractions, now what you're going to do is to work each bracket independently. Alright, so if you remember PEMDAS, some persons might say PEMDAS. This suggests that you should work what's in what? Parentheses first. Alright, whenever you have more than one parentheses, you work the one that comes first, moving from left to right. So this one comes first, so we are going to work that one first. Alright, so if you look closely to the first bracket, what's inside the first bracket? There is a what? Multiplication. So you need to remember how to multiply fractions. Whenever we're multiplying fractions, we look to see if we can cancel or reduce any numerator with any denominator. For example, 10 is a numerator and 3 is a denominator. You look to see if you can cancel vertically, or you also look to see if you can cancel diagonally. For example, this is a numerator and this is a denominator. You can also look the next diagonal as well. Now for this one, we can reduce the 10 and the 5 because they both have what? 5 in common. So let's go. So 5 into 5 goes 1 and 5 into 10 goes 2. Now we're going to investigate the next diagonal, right? If we look closely, we see that what? 3 is common to both 3 and 6. So 3 into itself, 1, and 3 into 6 goes 2 times. What are we left with? We are left with 2 upon 1 and what? 2 upon 1. Which is just, if you multiply just the numerators now, that will be 2 times 2, which will give us 4. And then 1 times 1 will give us 1. This is a whole number, which is 4, but because we're working fraction, strategically, I'm going to leave the whole number as 4 over 1 in opposed to just 4. Now, let's focus on the second bracket. In the second bracket, we are subtracting. Now, when we're subtracting, we're going to take a totally different approach from when we're what? Multiplying. When we are subtracting, we need to ensure that there is a common denominator. All right, so right here we have what? 3 and 5 as our denominator. So we need to find a number now that 3 and 5 can go into without leaving a remainder. No, that magical number would be 15 in this case. It could also be 30, but strategically we're going to choose what? The lowest one, just to ensure that we're working with the smallest numbers, which generally tend to be easier to work with. All right, so the LCM, or the lowest common denominator of 3 and 5, would be 15. Now we're going to do a little bit of division, even though it's still subtraction. We're going to say 3 into 15 goes 5 times, right? So we're going to multiply 5 times 10, and 5 times 10, or 10 times 5, that will give us 50. Then we're going to do this side as well. We're going to say 5 into 15, that goes what? 3 times, right? So we're going to say now 6 times 3, and then that will give us what? 18. All right, cool. So we are left with 4 divided by what? 15 minus 8 all over 15. Now 50 minus 18 all over 15 can be rewritten as, let me first write back the 4 over 1 divided by, if you subtract this, we're going to get what? 32, and that would all be over 15. Now in fraction, we don't divide, right? What we do is to convert our division to multiplication, because there's a relationship between multiplication and division. Now, multiplication is the inverse of division, and as such, what we do is simple. Write back the first fraction as is, then we're going to what? Convert the division to multiplication. Afterwards, we're going to reciprocate. The reciprocal process in this case is where the inverse comes in. In fact, another word for reciprocate is inverse. In some cases, they can be used interchangeably. All right, so this will now be 15 over what? 32. And now we're back at our multiplication problem. So let's investigate this to see if there is anything that can be reduced on the diagonal or on the vertical. As you can see, 4 and 32. All right, so 4 into itself, 1, and 4 into 32 goes 8. Since there's nothing else to reduce right here, we're going to multiply the numerators, after which we're going to multiply the denominators. So in multiplying the numerators, it is 1 times 15, which is 15, and then 1 times 8, which is 8. And your final answer is what? 15 upon 8, or if you like, if it's your preference, is to convert it back to a mixed number. You can simply do this by divide the 8 into 15, which goes what? 1 time, and that will leave a remainder of what? 7, and always remember, the denominator doesn't change. Alright, so that sums up this question. So initially, it might look difficult, but if you rewrite it as a horizontal problem, then you convert all the mixed numbers to improper fraction, and then you take your time to evaluate each bracket, you will surely get it. Alright, good job guys, and you have done well in watching, and I hope that you understood what I've done. Please stay tuned. I'll take the time out to work additional questions such as this one. Bye.
We'll be right back.